In 2006, a biotech firm called Conjichem thought they had discovered the holy grail of human performance. They had a compound that could elevate growth hormone for days with a single injection, but they abruptly shut the entire program down. Why? Because a healthy subject died of a heart attack. Now that drug was CJC-1295, and today, that exact same compound, it's being sold by the gallon on the internet to biohackers and 20-year-old lifters. Welcome back to the Barbell Medicine Podcast. I'm Dr. Jordan Feigenbaum, and today we're doing a forensic audit of the entire peptide market. Now, often billed to be safer and more effective than anabolic steroids, these compounds have been moving from underground forums and into mainstream longevity clinics. We got to look past the hype. Now, our goal today isn't to dismiss peptides out of hand, but to apply the same standard we use for everything else. What does the human data actually show? Are the results meaningful, or are we just looking at mechanisms in a petri dish? And to help us separate the signal from the noise, I'm joined by the second most handsome doctor in North America, Dr. Austin Baraki. Now, Austin, before we get into these specific molecules, we have to address why this topic is blowing up right now. In late 2023, the FDA essentially declared war on the peptide supply chain, moving dozens of popular compounds to a restricted list. Now, there's a massive amount of confusion here regarding what is actually legal, what is banned, and what is just plain dangerous. So to set the stage, we need to distinguish between three different bodies: the DEA, the FDA, and WADA. Austin, can you break down the difference for listeners between a drug that's scheduled for criminal activity versus a drug being restricted by the FDA for safety?
Yeah, I think a lot of the drugs that people think of as being quote unquote illegal are in that list of what are called scheduled controlled substances. The DEA is kind of responsible for that. There is a kind of a tiered classification of 1 through 5. And these relate to varying degrees of abuse potential, addiction versus potential medical use, and the degree of like monitoring that might be needed if somebody is to use some of these, depending on what level they're scheduled at. These are things on the extreme, like heroin, for example. Even cocaine technically has some legitimate medical uses still today. Testosterone is unfortunately on this list. I don't really think it should be, but it is. Xanax definitely should be on this list. Opioids, things like that. These are things that require a special DEA license, like one that I have, to prescribe, within certain restrictions and limitations and oversight regulation. But possession of these without a prescription is usually considered a crime. And now if you contrast that with a lot of these peptides, the DEA is not really paying attention to these at the moment. They're not scheduled. They're not on this list. There's not like a way that somebody with a DEA license can specifically prescribe you BPC or any one of these peptides. They're just not on that list at all.
So what you're saying is that the DEA isn't kicking down your door for having BPC-157, but the FDA has effectively nuked the supply chain. In recent years, you could get these from compounding pharmacies. Doctors could write a script, the pharmacy would make it, and all was above board. But in late 2023, the FDA moved many of their popular peptides, like BPC-157, to Category 2 of the bulk drug substances list. Now, Category 2 is the FDA basically saying, we have reviewed this and we see significant safety risks or no proof that it works, so you're not really allowed to compound this for humans anymore. And for the athletes listening, drug testing is a third separate category.
Yeah, we've talked about DEA, the medical prescription level that I tend to operate in that space. The FDA, which is even the bigger picture that has some authority outside of that DEA space as well. And then when it comes to sports drug testing, I mean, we've talked about these organizations on the podcast before, WADA, like the World Anti-Doping Agency, and then each, of its individual national affiliates like USADA. And these are also completely independent. They don't really care what the FDA has to say about anything. They also don't really care what the DEA has to say about anything. They have their own regulations and rules, mainly oriented around performance advantages or potential for performance enhancement in sport. And so pretty much everything that we end up talking about today for the purposes of sport performance and drug testing in sports is going to be pretty much prohibited. They have a few different categorizations: S2 category, S0 category. The details of this are probably not super important for people to distinguish clearly, but there are differences, for example, among peptide hormones, growth factors, things like that, versus things that are just straight up non-approved substances. And so this is something that you need to keep in mind if you are an athlete participating in a drug-tested sport, organization, federation, et cetera, because these peptides may well end up coming back to bite you.
Yeah, I think people assume that if their doctor prescribed it or if they got it off a website and everything was legal, then that's automatically included, like it's okay for sport, but that is definitively not the case. There's been a number of bans for these already. And while these manufacturers, particularly of the research chemicals, are trying to get sophisticated by like changing the molecule a little bit so it's not detected. Testing organizations, they're working on it to try to keep up with these individuals.
The never-ending battle. It's been going on forever. Will continue, I think.
That's right. So to recap, the DEA mostly doesn't care about peptides. The FDA says that doctors and pharmacies can't really give it to you anymore for safety. And WADA says, well, we'll ban you for using it. So overall, proceed with caution. So we have this regulatory crackdown happening because the FDA is looking at the safety profile of these specific molecules. But that raises the most fundamental question. What actually defines a peptide? Now, if you scroll through social media or you look at these research chemical sites, the word peptide is used as a catch-all for basically anything that comes in a vial and can be bought with Bitcoin. But scientifically, that's not quite right. In pharmacology, we classify drugs based on their size and their complexity. Now, this isn't just a matter of semantics. It dictates whether you can swallow a drug as a pill or if you have to inject it. To understand why the FDA drew a bright line around these compounds, we need to look at where they sit on the molecular spectrum. Think of drugs like vessels in the ocean. Small molecules like aspirin, well, they're rowboats. They're tough enough to survive the storm of your stomach acid and small enough to slip inside cells. Biologics like growth hormone are aircraft carriers. They are massive and they are complex. You cannot swallow an aircraft carrier, your stomach would tear it apart. That is why these drugs mostly are injected. Now, peptides are the speedboats. They're in the middle. They're faster and more complex than rowboats, but generally too fragile for the digestive tract. And actually in 2020, the FDA established what's known as the bright line rule. Basically, it says if a drug has 40 or fewer amino acids, it's legally considered a peptide. If it has 41 or more, it's a protein or a biologic. So semaglutide, that's Ozempic, Wegovy, etc., is 31 amino acids long. That is under the limit, so it's technically a peptide. You compare that to insulin. Insulin is 51 amino acids long. That crosses this bright line. So technically, insulin is a protein drug. Now, historically, speedboats were still too fragile for the stomach. So if you ate a peptide drug, your body just recognized it as a protein and digested it into amino acids. It technically becomes expensive urine. But Austin, I know people who have listened to our podcast before, they're going to be screaming either at their phone or their speaker. Well, what about Rybelsus? That's oral semaglutide. How does that work here?
Yeah, I mean, first of all, there's really no reason to scream, but we can address the oral
All
semaglutide conundrum. And it really is an interesting exception because by and large, to date, the approved GLP-1 receptor agonists and multi-agonists that we addressed in our last episode are pretty much all subcutaneous injectable drugs, going way back to exenatide and liraglutide, dulaglutide, et cetera, since then. But as the science has kind of progressed, the drug pharmacologic engineering has progressed, there's obviously been this somewhat holy grail of having an oral formulation of these medicines, because the thought is that there are some people who might be needle phobia or just prefer oral medicines, or potentially if we can formulate an oral medicine that works, it might be more convenient, more accessible, less expensive. There's various reasons to at least try to pursue this, whether or not it's to somebody's individual personal preference. And so for oral semaglutide, which is currently branded under Rybelsus, used for diabetes, it is kind of an exception here. They had to do some really fancy pharmacologic engineering that is way outside of either of our wheelhouse. They had to combine it with this, what's called an enhancer known as a SNAC, S-N-A-C. And that basically facilitates oral absorption of these peptides that would otherwise be digested. So it helps it kind of evade that breakdown in the stomach and ends up getting absorbed. Despite that, it still does not have great what we call oral bioavailability. And so that's why, for example, if you look at the milligram doses of oral semaglutide that are common used at the moment, it's dosed at 3, 7, or 14 milligrams. And it's being studied up to 50 milligrams. Well, if you combine that with the injectable versions that go into the skin, that starts at 0.25 milligrams with a max dose of around 2.4. And so there's almost like a 50-fold difference in absorption efficacy. And that's why you have to use such higher doses of the oral formulations to get it absorbed. It really is a pretty impressive feat of the pharmaceutical engineering. But there's some really fancy stuff that has to get done to turn that oral peptide into something that's absorbable and then delivers efficacy. And so this has implications if you think that some of these other types of peptides that you might be buying from wherever on the internet, how effectively, if they're orally, delivered, how much you're actually absorbing, whether they're getting to where you want them to get to have the effect that you're looking for.
Yeah, people are like, oh, I can get oral BPC-157, which is traditionally sold as like an injectable for subcutaneous administration. They're like, no, but this one's oral. I can just take it by mouth. And it's like, yeah, what are the odds that they, have this likely proprietary, pharmaceutical enhancer attached to it.
Yeah, not so simple as taking an injectable medicine and then just like squirting it in your mouth instead. There's relatively few drugs that work equivalently both ways.
Now, just for the listeners at home, in the hospital, does this distinction, between a peptide and a protein actually change how you think about a drug's safety or how it behaves in the body? Or is it mostly like a regulatory hurdle where you're like, well, it's classified as this and this is the administration, but I don't really think about this?
Yeah, not really something that comes up in clinical decision making. I bet if you even ask most folks, who are practicing clinicians who use all sorts of these drugs, they might not be able to confidently distinguish between which is technically a peptide and which is technically a protein. Now, as far as the biologics go, yes, in general, we know which ones are biologics. They're a whole separate class that we think about very differently, most of the time because they're significantly impacting immunity. And so then, I really want to know, is my patient like immunosuppressed or immunocompromised? But outside of that, like the simple structural differences, not really something that's relevant outside of just knowing what is this drug? What are the potential benefits? What are the potential downsides? What do I need to think about when considering using it in a patient? But that's pretty much the extent of it.
Yeah, that makes sense. Nobody's like, well, this has 51 amino acids, so this is the specific consideration for it.
Nope. Using insulin every single day and without a thought to its chain length.
There you go. All right. Well, the compounds that we'll be talking today are either peptides, those are the speedboats, or the small molecule drugs, those are the rowboats. But for ease of understanding, we'll collectively call them peptides, even though that's wrong and it will annoy Austin.
Yeah.
He'll allow it. All right. So the excitement over peptides, though, for improving health and performance, to me is understandable. So if peptides are these speedboats, targeted and mid-sized, that leads us to the biggest selling point in the industry. The promise that while steroids are a shotgun, hitting the muscle, but also the prostate, the hairline, the hematocrit, peptides are billed as a sniper rifle. They claim to hit only the receptor you want without the systemic tax. But as we're about to see, that specificity is often more theoretical than reality. Austin, can you think of an example in medicine where something like this actually plays out?
Yeah, tons of them, where we have differences in terms of the kind of specificity of our treatment. And just a couple examples. So one has to do with what I actually just alluded to with the immune modifying drugs. So prednisone, for example, or a glucocorticoid is kind of like that shotgun analogy. It is about as potent of we'll call a broad spectrum anti-inflammatory as we want. Most types of inflammation, not all, but most, it will tend to heavily suppress, particularly if you use high enough doses. But it has a lot of those off-target effects. That's why we really don't like having people on very high doses of prednisone or for very long periods of time, because it can impact the bones and body fat and muscle and blood sugar and your brain and your sleep and all sorts of different things. Fortunately, as time has gone on, we have developed a lot more specifically targeted immunomodulatory drugs to target specific elements of the immune system. So in contrast to that shotgun, for example, the anti-TNF drugs. So for example, Humira is one that many people in the audience might be familiar with. They might know somebody who is on these. There are, even that one is getting a little bit older now. There are much newer, hotter ones that are targeting specific interleukin signaling pathways or others that are targeting just that specific signaling pathway and leaving everything else untouched. That doesn't mean that these don't have potential negative side effects or things like that. It's just mitigating, and we're much more comfortable having patients on these long term compared with something like prednisone long term. Another even easier example for people to understand is the use of antibiotics. On one hand, if I have somebody who comes in who's extremely ill and I have no idea what's going on, I'm probably going to just blast them with the broadest spectrum antibiotics that I can that kills kind of everything. And then the more information I get, I can target it more specifically to the organism that I have identified that I'm trying to kill. So there's that difference in the broader spectrum effects versus the more narrow targeted spectrum effects. And so there can be reasons to go in either direction that are perfectly valid in practice. And so I think here in the peptide space, a lot of these are billed for having very specific targeted effects that people might be seeking. And of course, if you're comparing it with, instead I went to my doctor and they wanted to put me on a course of prednisone or something like that for that, it's like, yeah, that would be an attractive, alternative to me too, because I would really try to avoid taking a medicine like that if I had any other feasible option that had efficacy.
Yeah, especially, again, if there was a lot of evidence to support these very specific targets without any sort of unintended consequences.
Yeah, exactly.
And so typically we call that like pleiotropy, but usually we're referring to that as in a positive setting. So for example, with like the GLP-1 receptor agonist, we're finding a lot of like unintended benefits.
Yeah.
So it's like positive pleiotropy, but it could also be negative. In the case of maybe a peptide that like BPC-157, many people think, oh, well, it's whispering to the specific receptors on your tendons only to grow or remodel, repair. But that might also be hitting a receptor on like a precancerous polyp in your colon that could be listening to the same frequency. And when that polyp hears grow, it doesn't ask for permission, it just grows. We just don't know that yet based on evidence. But pleiotropy can be positive or negative and with more extensive research, which is a nice segue into each peptide that we're going to discuss. And we're going to start off with the growth hormone agents. This is the first category. I like to call this an anabolic mirage. Now, these are growth hormone secretagogues, meaning that they increase growth hormone release. They basically cause more growth hormone to be released. So we're going to start off with CJC-1295, and they're basically viewed as like a diet HGH, or again, HGH without the shutdown. They're marketed as the ultimate recovery tool to build muscle and lose fat by naturally boosting your body's growth hormone levels around the clock. Now, the history of this particular peptide, it was developed in the early 2000s by Conjichem for HIV patients to treat lipodystrophy, which is abnormal fat distribution. So the mechanism of action, you can think about your pituitary gland as a factory that ships out growth hormone in batches or pulses. Now, there are two different versions of this. One is CJC-1295 with DAC. This is a manager who basically nails the doors open, creating a constant bleed of growth hormone into your system that can last for a week. Basically, it's a long-lasting version of this peptide. And then there's MOD-GRF, which is a manager who tells the factory to ship out a bigger batch right now. So two different versions of the same type of peptide. As far as the evidence base on this, human data confirms that this peptide raises both growth hormone and insulin-like growth factor 1 or IGF-1 levels. However, the phase 2 clinical trial of this peptide was halted due to a patient death, leading to its commercial abandonment. Now, Austin, for the non-clinicians that are listening, can you explain the gravity of a trial being halted for a death? Like, how does that differ from the typical side effects we see in an approved drug?
Yeah, I think it is reflective of the pharmaceutical kind of testing system working in a way that we would like it to. In other words, they're generally going to be kind of risk averse and take these types of things very seriously when they happen. It does not automatically, in all cases, imply that, oh, the drug definitely killed this person. There's a lot of details that you'd have to sort out to try to what's called adjudicate that. You have to determine, did this person just die? You know, you could be enrolled in a trial and get hit by a car and die. That doesn't mean that they're going to halt the trial for it. But if there is a plausible potential mechanism, for example, or if the patient presented very ill in like acute liver failure after starting a new drug, it's like, well, that's actually a relatively common sort of thing that can happen on exposure to new medicines. And so this would need to be investigated and, as I said, adjudicated, determined before we can make decisions about the ethics of proceeding with continuing the trial or with, running additional trials in the future. This is why things like institutional review boards also exist to look over, trials and have them planned out very ethically and carefully and cautiously so that when we have humans who are volunteering to be participants in a study, they're not volunteering for their own death. And so again, I don't want to blow this out of proportion right away and say, oh, definitely this will definitely kill you if you take it, but rather that it is a signal for something that we would hope doesn't happen in a clinical trial that deserves extra scrutiny. And so I'm not surprised that happened.
Yeah, when digging into this, the research group that was doing this phase 2 clinical trial was like, well, this person who died may have had like a pre-existing heart condition, for example, and maybe that's
always possible.
This. But ultimately, it was commercially abandoned, and so from there's been no real studies in humans, and there's absolutely no human data on performance, long-term health, body fat management, lean body mass, anything like that. None. There's some known side effects that have been reported here. So the long-lasting version or the bleed version, the one that contains DAC or is attached to DAC, is highly prone to inducing some level of insulin resistance and joint pain, which we call arthralgias, which does not seem like a good trade-off.
Those are expected things from constant, exposure to growth hormone signaling. Those are not surprising effects. And so, when you describe the mechanism of like, oh, we just want a constant bleed of growth hormone nonstop high levels for a week, I'm like, I don't think I want that because there's a lot of downsides to that,
Yeah. So overall, this drug class and this particular peptide, there's this kind of underlying assumption with these growth hormone promoting agents that, hey, if you raise growth hormone, that's generally good. But the data on even human growth hormone administration itself in folks who don't need it, so these are folks that are non-deficient, in human growth hormone. It's not very good, even when it's given at super physiological doses. Now, I know people follow bodybuilders, and a lot of these individuals are taking growth hormone or something that would otherwise increase their growth hormone levels, but this has been studied. It doesn't seem to increase actual muscle mass. Lean body mass can go up, but mostly that's a lot of water and glycogen when studied here. It's not good for strength. Okay. It's not good for VO2 max. And so when, from a kind of like predicting whether or not this is likely to be true, raising human growth hormone in and of itself does not seem to be like a very anabolic or like performance enhancing sort of mechanism to me. We know that fasting, for example, increases human growth hormone. Exercise itself increases human growth hormone, but these are mostly related to energy status rather than like tell your muscles to grow or tell your body fat to decrease. I'm not really sold on like, we should try to be maximizing human growth hormone for this application.
You wonder how popular it would be if it had been named something else from the beginning, or if it's the name that makes it,
growth.
Right?
Yeah, exactly.
It has good branding.
Yeah, exactly. All right, we're going to move on to the next agent. So that was CJC-1295. This is another growth hormone sort of stimulating product called Ipamorelin. This is billed as the cleanest peptide for growth hormone. Proponents argue it is the only way to boost your growth hormone levels for better sleep and recovery without the hunger pangs, stress, or water bloat associated with other peptides in this class. As far as the evidence on this, human data certainly confirms its selectivity and safety, but it failed its primary clinical endpoint of improving gut motility after surgery, which is why it was abandoned by pharma. And there's zero human data for muscle growth, body fat loss, or other outcomes. As far as side effects go, it seems to be pretty safe. No spikes in cortisol, prolactin, or increase in hunger, anything like that. So it does seem to increase growth hormone in humans, but I'm not really sure, again, that does anything. It's kind of like a mechanistic bet. Yeah, it increases growth hormone, but what does that do? It's just using a mechanism to predict an outcome that doesn't really seem to be there, even when people are getting the actual thing you're trying to increase, which is human growth hormone. And there's no long-term trials here. So I don't know. What do you think about this?
Yeah, I don't think that either of us are volunteering to use this or to experiment with it ourselves. But for example, if we contrast it with the last example, this one certainly seems a lot more promising, even if it's just from the safety standpoint. And so, yeah, to be more confident with using something like this for performance enhancement, or if somebody was looking to do that, or if one of us was interested in something like that, we would certainly prefer to see compelling human evidence. And, I think that the idea that we're going to get very long-term human trials on any of these things is super unlikely. And so you could probably just paint with a really broad brush and say there's not long-term trials really in any of these. Even if you had a shorter term human trial, that would be preferable to having none. And so that would ideally be the next step. And so I wouldn't be surprised, given that, hey, this does seem to do what it is billed at doing mechanistically at the receptor level and things like that. Seems like a promising agent that, with the right incentives, somebody might study a little bit further to better characterize. Because if it does, in fact, even offer any advantages over giving actual human growth hormone, the recombinant type that might be used in patients with growth hormone deficiencies and things like that, then cool, then there's a clinical use for it. But not for us at this time. But I can see why people might gravitate toward it.
Yeah. I think if there was a good signal, it did something, then you would see it, progress through the clinical trial phases to phase 3, and then ultimately make it to market. And then you would have some long-term, phase 4 observations here, just to see like, oh, look, people who have taken this drug for a year or 2 years, here's the outcomes. But yeah, I suspect that wouldn't happen unless there's some promising initial data. Unfortunately, it's been abandoned.
Yeah.
So CJC and Ipamorelin are the injectable options, but the industry knew that if they wanted to reach the mass market, they're going to need a pill. And that brings us to MK-677. This was the first drug designed to successfully bypass the needle while still hitting the growth hormone axis. This is billed as the ultimate oral mass builder. It's marketed as a pill that gives you the recovery of human growth hormone plus a primal hunger that allows hard gainers to finally eat enough to get massive. So you can kind of think about this as a sustained hunger mimetic, because it does bind to the ghrelin receptor. Now, if you remember, ghrelin tends to increase hunger, but when you stimulate this receptor, it also tends to increase growth hormone. So when you fast, for example, or you're between meals, your human growth hormone levels go up. That's just a kind of an energy balance related signal. And so by stimulating this receptor, you also get an increase in growth hormone. So on the one side, this signal hits the hypothalamus to increase hunger. That's ghrelin's sort of one of its functions. On the other side, it also tells the pituitary gland to release large, frequent pulses of human growth hormone. They basically balance each other out, though, so there's apparently no significant increase in fat mass. So you have more hunger going on, and people may consume more calories, but the increase in growth hormone does seem to prevent any additional weight gain. As far as the evidence on this, that's kind of what was found. There was a landmark 1-year study in healthy seniors. 25 milligrams of this peptide, MK-677, increased IGF-1 levels by 60% and lean body mass by about 1 kilo. Concerns about whether or not this was actually skeletal muscle mass. Again, that's the problem. Lean body mass is not just muscle tissue. It's everything that's not fat. So that includes things like water, bone, visceral organ tissue, glycogen, etc. So not sure if this is really skeletal muscle tissue. And again, there was no increase in fat mass, like we said, despite the increase in appetite. And the reason why there was this concern that the lean mass increase wasn't actually muscle tissue is because there was zero improvement in strength, power, or physical function in these seniors. So the active muscle tissue to me was likely water and glycogen, or like bloat rather than, quote, functional muscle. We see that in other studies on actual like human growth hormone and other agents in this class. So yeah, to me, I think this, agent, while it does avoid fat gain, which we would be against generally speaking, it comes with a high metabolic tax. By constantly mimicking hunger and raising growth hormone, it forces the body into a state of physiological insulin resistance. In trials, participants saw a significant rise in fasting blood sugar and hemoglobin A1C. That's a measurement of how what your blood sugar has been like over the past few months. It essentially trades the aesthetic problem of body fat for the clinical problem of prediabetes. Other common issues include severe, quote, moon face, which is like edema of the face, and again, joint pain, arthralgia. So, Austin, we're seeing these young adults and others taking this peptide for months at a time. If a patient shows up to your clinic or you have an online consultation with them and they've got a rising hemoglobin A1C, they've got a puffy face with edema from this peptide, how would you explain the long-term risk to someone who's only focused on scale weight?
Yeah, I think while it might be tempting to just right off the bat tell the person to stop, we know that doesn't tend to work very well, and you might immediately ruin your rapport with the person, and they might never come back and see you again. And so I would just, as I have talked about before, with respect to behavior change and belief change, ask like, why are you taking this? Tell me your thought process. Tell me your reasoning. Tell me your goals. Tell me how you got there. And then kind of what are they experiencing while they've been on it? And are there any downsides that they have experienced? And then from there, I might be able to tie in my concerns specifically that they're developing insulin resistance, which despite nearly whatever aesthetic effects that they might be enjoying, maybe not, that insulin resistance is something that is at the root of so many different diseases that are very common these days, can lead to potentially devastating long-term complications ranging from stroke and heart attack to many other things as well. So I would just, elicit the person's beliefs and goals, and then see if I could tie in my concerns and see if I can get them on board with the idea of, hey, maybe not the move here.
Yeah, you're trying to basically build this therapeutic alliance with the person. So you can't right out of the gate and say, yeah, not only does this thing not work, I have concerns about its safety.
Yeah.
More so trying to figure out why do they believe what they believe, and then seeing if there, like you've mentioned so many times, are there any threads to pull on here?
Yep.
All right, the last compound in this anabolic Mirage category. These are drugs that increase growth hormone. It's Tesamorelin. Now, this is the only FDA-approved drug in this list. It's for lipodystrophy, or abnormal fat distribution in individuals with HIV. It's marketed as a targeted visceral fat assassin that specifically strips away the hard, dangerous fat around your organs, and maybe reveal your six-pack while improving your memory. So a lot of interesting stuff that are claimed on Reddit. That's where I scrubbed for what claims are being made about these agents. Mm-hmm. As far as the history of this drug, it was developed by Thera Technologies, and it was FDA approved in 2010. It was created again to treat HIV-associated lipodystrophy. Patients on early antiretroviral therapies, those are medications used to treat HIV, they were developing accumulations of visceral fat, and it's belly fat, that couldn't be solved by diet and exercise alone. So visceral fat cells, again, belly fat, they're incredibly sensitive to growth hormone. Tesamorelin stimulates a powerful pulsatile release of growth hormone that appears to go straight to these belly fat reservoirs to burn them off. And there's good human data on this. It successfully reduces visceral fat by 18% in HIV patients on average, but there was no weight loss. There was also a phase 2 clinical trial for executive function in seniors, although these results were not conclusive, showing really no significant effects compared to placebo, but potentially something there. And again, there's no data on performance in other individuals. Like if you're a healthy young person taking this, does it increase your lean body mass? Does it decrease fat mass? We don't know. As far as the toxicity goes or side effect profile, it's well characterized. Joint pain is a potential sort of side effect and a relatively mild increase in blood sugar. So there's some concern there, but less than the other agents. So to summarize, this is an FDA-approved drug for reducing visceral fat. The problem that is most reported on Reddit for this particular agent is that it's very expensive. It's thousands of dollars a month for pharmaceutical options. However, many wellness clinics and only 18 providers offer research chemicals or compounded versions that are around $200 to $600 a month. Interestingly, we have new medications that are actually better than this drug for reducing visceral fat, like tirzepatide, Zepbound, Mounjaro, even Ozempic and Wegovy. They not only cause more weight loss, and because they cause more weight loss, you get more reductions in belly fat on top of that. They're also cheaper, appear to be safer, and have more like additional benefits than this particular agent.
Yeah, I mean, there's the cardiovascular benefits, the renal, kidney-related benefits, the liver health-related benefits, and many others that are being characterized on an ongoing basis. So I'm kind of with you. You know, this is not a drug, while I'm aware of it, it's not one that I've ever had to use. And I think the main reason why is that original indication that it has for HIV-associated lipodystrophy is fortunately something that we see less and less of these days. Those original HIV drugs, mainly in the class of what are called protease inhibitors, they caused this horrific metabolic dysfunction, insulin resistance, and visceral fat accumulation. Those drugs we use less and less of these days because we have newer and much better agents to treat HIV that don't come with that negative side effect. There are still other drugs that can cause that type of dysfunction. Some of the drugs in the quote unquote antipsychotic class that are often used for various mood related disorders and things like that can contribute to weight gain and visceral fat accumulation. So there's still kind of to some extent a need for being able to manage these things. But now we're, as you alluded to, studying the situation of, hey, this patient really needs a medicine like olanzapine in this antipsychotic class that can contribute to this. Okay, well, if we treat them at the same time with a combination, say, of metformin and tirzepatide or something like that, then we can, how much of that insulin resistance and visceral fat accumulation can we ameliorate while maybe even getting them benefits in other ways related to their mental health issues, to substance use, to heart, to kidneys, to liver, etc. So that would be my move if I was in this kind of situation. If I had a medical condition that was contributing to a ton of visceral fat accumulation, I would be looking in those territories before I came to something like this.
Yeah. I agree. All right. Well, we're going to move on to the next category of peptides. This category I call the healers. We're going to start off with everyone's favorite, BPC-157. So the claims are that BPC-157, it's the holy grail for injury rehab. The claims are that it can physically knit together torn tendons and ligaments in a fraction of the time, allowing athletes to bypass surgery and return to the platform or the competitive arena within weeks. This was isolated from human gastric juices, that's basically the stuff in your stomach, by Croatian researchers in the 90s. It was named BPC as an acronym for Body Protective Compound. As far as its mechanism of action, to the extent it's been characterized, you can think of BPC-157 as a fertilizer for blood vessels. One of the reasons that tendons heal slowly is because they have little blood flow, poor blood flow. And it's thought that BPC-157 forces the body to sprout new blood vessels, that's angiogenesis, into the injury site to bring in repair cells. There may be some modulation of the nitric oxide system as well, which can cause vasodilation to further increase blood flow to the area. Now, as far as the evidence on this, we covered this on a previous podcast. I think it was episode 298. I'll link that in the show notes below. There is zero published human randomized control trial data for BPC-157, period. Zero published human randomized controlled trial data for BPC-157, period. And that includes sports injuries, that includes gut health, anything you want to say. There's no human data on this. Most of this miracle healing evidence comes from rats and from a single research group, the ones that discovered the peptide. There has been a small human pilot study on knee pain where basically this clinic that prescribed the drug called about a dozen individuals and said, hey, is your knee pain better? And then got an answer, yes or no. That's the only human study on this, period. There were phase 1 and phase 2 clinical trials conducted for ulcerative colitis in the early 2000s, but the results were never published and development subsequently stalled. As far as like does this make sense, test? Yeah, sure. Tendons need more blood flow in order to repair and remodel. And BPC-157 brings blood. However, the sheer breadth of the claims around this agent, it heals the brain, the gut, the bone, muscles, tendons, corneas. That's biologically suspicious to me. A drug that heals everything usually does so by overriding safety checkpoints like apoptosis, which raises long-term safety questions. So, and on top of that, when I see something that does everything, I kind of initially think maybe it does nothing, to be honest. What do you think about that?
Yeah, I have a similar take when I see something touted for everything. Although the caveat is that is when we do not have clear evidence indicating that it does those things, because somebody might hear you and then say, well, if I rewind like 2 minutes, I just heard you talk about GLP-1 receptor agonists helping with, heart and liver and kidneys and neurologic stuff. And I think part of the difference is that there is a shared underlying mechanism of all of the conditions there that are being addressed, oftentimes related to excess body fat and insulin resistance and some inflammation and things like that. And so by targeting that systemically, we're seeing benefits in multiple different organ systems. But most importantly, aside from all that mechanistic stuff, is we have human randomized trial data showing that people die less. They have fewer heart attacks. They have less kidney failure. They have better outcomes with respect to fatty liver disease and things like that. So that we have that at least that we can point to. Here, if there's a lot of claims about it having significant, health benefits across all of these different systems, I'm open to the possibility that there is something there, but you kind of have to show me. You have to convince me, and it requires more than just mechanistic kind of hand waving or speculation or saying it should do this or it should do that, because the history of medicine is littered with things that we thought should do something beneficial and then either turned out to do nothing or in some cases actually did quite a lot of harm to people instead. And the other aspect of this that you mentioned, some of the stuff that came to mind is like, oh, if it helps by increasing blood flow to tendons, there's a lot of ways to do that, right? It doesn't have to be this particular peptide. So if that's the only mechanism that you're promoting, I have some questions and I'd want to see like, okay, is it better than activity? Because that can increase blood flow. There are even people who use topical nitrates on tendinopathy. I have my skepticism about the use of topical nitrates for tendinopathy, but that's another way. It causes vasodilation, increases blood flow, things like that as well. So we've come at this problem a bunch of different ways. And so it's one where, again, it's like, okay, well, if it is at least, if we can at least feel confident that there is safety here, then I'm open to the possibility of further exploration. But before I make confident claims, or certainly before I recommend it, and definitely before I prescribe it from, a source of unclear, quality, then I just want to feel better about that instead of hawking it overconfidently with, underdeveloped backing.
Yeah. So overall, the safety in humans is unverified, and that's even before we get into efficacy. But the FDA recently banned it from compounding, citing significant safety risks like immunogenicity. This effectively banned legitimate U.S. compounding pharmacies from creating it, pushing users to the black market, so like research chemical sites. So Austin, quickly, what is immunogenicity and why is that a concern?
Immunogenicity is something we've talked about a couple times before. I think if people want to go back to our episode on exercise as it affects the immune system, this is probably from a couple of years ago now, but immunogenicity refers to the ability of a substance, an antigen, a drug, an exposure, whatever the thing is that is stimulating, to actually provoke an immune response in the human body. And so when the body recognizes something as foreign, again, it could be a drug, it could be a pathogen, it could be not a pathogen, but something you're allergic to, it could be even your own body if you have an autoimmune disease, then it produces antibodies and other kind of immune effectors against that thing. And so the more it kind of revs up your immune system, the more immunogenic we would describe it as being. And so, in this situation, if you're injecting a peptide or a drug and that drug itself is immunogenic to itself, then you can generate antibodies to that very substance. And those can be binding, meaning that they bind the drug and can accelerate its clearance because the body says, look, this drug is now tagged with all these antibodies indicating that I need to get rid of this. Or it could be neutralizing, where it doesn't necessarily bind it and accelerate its clearance, but rather prevents it from having the effect that it wants to have. And so if a drug or a substance that we're giving somebody itself is immunogenic, then we have concerns that it is going to be ineffective altogether, or it might progressively lose its efficacy as the immune system learns to either prevent it from doing its thing or accelerating its clearance by way of antibodies or other immune-mediated responses.
Let me break down why the FDA is worried about immunogenicity. When you inject a synthetic peptide, your immune system might see it as an invader. It creates a most wanted poster for that protein. Now, the danger is that this poster might look so much like your own natural proteins that your immune system starts attacking your own body by mistake. That is a permanent systemic risk that you do not want to take for slightly faster recovery.
It's indicating that it does.
Theoretical. I can already hear or envision the people who love this compound. They think it healed their rotator cuff, it healed their knee tendinopathy very quickly. They say, well, look, man, it works, and I don't care what you guys say. And it's like a lot of things improve pain. Time improves pain. A lot of different placebo-mediated things improve pain. And so just because it, quote, worked for you does not, we should not attribute that to the actual compound itself, especially if we're trying to make broad recommendations to individuals. I have serious concerns about that.
Yeah, this has also been a recurring topic for us. I'm not here to argue with people's experience if they say it worked for them and they're willing to spend the money, take whatever risks there are. I've had patients who decided, hey, for one guy who I remember years ago decided, hey, he has bad enough shoulder osteoarthritis and he was willing to do pretty much anything except get a shoulder, arthroplasty or a shoulder replacement. So he flew down to Central America and got like stem cell harvests done, and then flew back a few months later and then got him injected back in his shoulder. And I'm like, okay, like there's going to be, I would expect, a pretty significant placebo type response because of all the cost and expense and time and effort that went into that. But I also know of a lot of tropical and exotic infections that I see coming from patients in South and Central America as well, just because that's, something that happens in those parts of the world. Of course, we have our own too in North America, and everywhere else has its own type of distribution of these things and complications. And indeed, spinal, epidural, steroid injections, various other types of joint injections over the years, stem cell injections have led to documented infectious complications and things like that as well, from contamination or improper technique and things like that as well. If somebody says, hey, I'm fine with all those risks, those things are treatable on the back end, I'll survive it, whatever. It's like, okay, then you are entitled to make those decisions. Once somebody is adequately informed on these things, I actually don't take like personal affront if somebody decides to pursue something of their own volition. That's fine. I'm just here to be an advisor.
Yep. Yeah, I like that. So to me, overall, BPC-157, it's the Wolverine that hasn't crossed the species barrier yet. The rodent data is spectacular, perhaps too spectacular, and it's heavily concentrated from a single research group. The lack of human trials after 30 years of research, to me, is a massive red flag, in addition to like sourcing it from a trusted place rather than research chemicals off a shady website. And the leap here is that this is an eye drop drug that individuals have decided to inject into a quad tear, thinking it could work to repair their muscle fibers. But there's really no data to support this. It was isolated in 1981, and it is essential for how our cells move to repair wounds. So there's human data for surface wounds, so venous stasis and pressure ulcers. There's two phase 2 randomized controlled trials that found that topical gel accelerated healing by nearly a month in patients who received TB500 compared to placebo. However, it did not always show a statistically significant difference in the total percentage of patients who achieved wound closure. It also failed phase 2 clinical trials to help cardiac regeneration after a heart attack in humans, despite miraculous results in mice. There's zero human data for muscle tears at all. As far as toxicity concerns, chronic use may carry a theoretical cancer risk, as cancer cells hijack the same slippery mechanism to spread to other organs. We call that metastasis. So some theoretical risk there, but again, no data on it overall. To me, the data isn't awesome for humans outside of some eye conditions and maybe some surface wounds. Otherwise, it's unproven. It does share the same tragic fate as stem cell injections for joints. Spectacular mechanistic hype and animal data, but generally not so impressive results in high-quality human trials. And then there's another problem. TB500 is a synthetic fragment of the full peptide, which is thymosin beta 4. That's what's been used in the clinical trials above, but the gray market primarily sells the fragment, TB500. So we're seeing people take this fragment of a protein and assuming that it does the thing that the whole protein does. Austin, have we seen other instances in medicine where a small peptide fragment failed to live up to the parent molecule's reputation?
I mean, biology is just really complicated. Proteins can get sliced and diced in all sorts of different ways, and that can lead to differences in the downstream function, again, depending on how these proteins get cut up. So, in clinical practice, the things that I kind of see and use on a regular basis that have some variation, despite kind of a shared origin, are things, peptides in the body like BNP or brain type natriuretic peptide, and the NT-proBNP, which is kind of a cleaved variant of that. And then another one has to do with the idea of pro-insulin getting secreted and getting cleaved into insulin, and then C-peptide as well, which are different things that do not share the identical effect, even if you might assume that they both indicate the same thing. They're going to have different levels, different interpretations, different clinical uses. And so, yeah, not a safe assumption to say that, hey, this tiny piece of the fuller protein is going to deliver the same clinical effects just because it's part of the bigger daddy molecule.
Yeah, can you imagine if these research chemical sites, instead of selling insulin, they sold C-peptide, and they're like, look, this will lower your blood sugar, way to,
Yeah.
optimize your nutrient partitioning. And it's like, if you gave an individual with diabetes a ton of C-peptide, it does nothing
Yeah, right.
because it's just not an active fragment.
Yeah, agree.
All right, moving on to the next one. It's GHK-Cu, this copper peptide. Now, the claims here are that this is the ultimate biological reset for aging. Proponents argue that it restores the skin's youthful snap. It rescues hair follicles from dormant states like balding, and acts as a software update for your genes, instructing cells to prioritize repair and collagen production over scarring and decay.
Man,
This was
Reddit's wild if they're making all these claims. I've never heard of this thing, so this is education for me.
All right. So this was isolated in 1973 by Dr. Lauren Pickart, who noticed that plasma from young donors made liver tissue from older donors behave as if it were decades younger. So you can think of this peptide, GHK-Cu, as a copper courier. Now, your body needs copper to build the structural scaffolding of your skin and hair, but free copper is toxic and hard to transport around the body. So this peptide acts like a specialized armored truck that picks up copper and delivers it directly to the cellular construction crews. As far as the data on this, human data for wound healing is pretty significant. A 2% topical gel significantly increased ulcer closure in 120 individuals with diabetes. For cosmetic skin quality, the data for wrinkles and skin rejuvenation is not quite as good. There was a trial of 71 women that showed that there was increased skin density and thickness with use of this agent. But these studies, again, are small, they're short term, less than 12 weeks, and rely on surrogate markers like ultrasound density or subjective grading scales rather than long term dermatological outcomes, things that we can measure reliably. This is the same problem we saw with like collagen supplementation. It's like skin elasticity, and then you look at the actual test and you're like, well, this test actually doesn't seem very good. Even though it improves the outcome of that test, does it actually improve how people look in some sort of way that we can reliably measure? As far as toxicity goes, it appears to be pretty safe when applied topically. When injected, it's notorious for a burning sensation at the site. Toxicity at typical doses is unverified, but theoretically could carry a risk of like copper toxicity, I suppose. So to summarize, I think this is probably fine for as a topical agent for wound healing. The skin data I am not convinced on, and there's no human data for like any sort of systemic performance improvement or recovery from like injury. To me, it's kind of like vitamin C. We know that we need it for collagen production, and like if you're deficient in it, that can hold things up. But mega dosing it doesn't seem to make it work any better, and can in fact cause some harms.
Yeah, interesting. Presentation that you put together on this one here so far. I would have certainly less concerns about somebody who wanted to use this compared with some of the other ones we've talked about so far, especially if it was isolated to topical use. I think anything systemic that you're injecting with essentially no or very limited human data, typically in most situations is going to carry a little bit greater potential risk. But yeah, this one seems more benign, I suppose.
Yeah, especially if someone was doing it topically, there'd be limited amount of pushback. But
Yeah,
injecting it, I'm like, are we sure that that's a good idea?
right.
But again, important not to break the therapeutic alliance.
Yep, I agree.
Moving on to the next category, these are the metabolic modulators. Starting off with one of the hottest new drugs that's likely to be approved soon. This is Retatrutide. This may be the Godzilla of weight loss. It's presented as metabolic bariatric surgery in a vial, claiming to melt away nearly 30% of your body weight, not just by stopping your hunger, but by actively revving your metabolism like a furnace. So this is a triple agonist from Eli Lilly, currently in phase 3 trials. They just wrapped up, I think, the Triumph study. The mechanism of action, it's similar to Mounjaro, Zepbound, in that those are they have two sort of agonists, the GLP-1 and the GIP agonist, but Retatrutide adds a third signal, which is glucagon. And this tells the liver to actively dump fat and burn calories for energy, really mostly heat in this case. So it addresses both sides of the calories in versus calories out equation. As far as the human data on this, it's pretty good. They just wrapped up Triumph 4. This showed an unprecedented 28.7% weight loss at 68 weeks. And this was for individuals with obesity and knee osteoarthritis. So in these individuals, the average weight loss was 28.7%, up to 71 pounds at 68 weeks. And beyond just weight loss, it reduced knee pain as measured by the WOMAC scale by 76%. Demonstrating that the weight loss and potentially other effects of the medication improved pain experience. By comparison, the placebo group only lost 2.1% of their body weight. Also has some interesting effects on metabolic associated steatic liver disease, also known as non-alcoholic fatty liver disease. They had a phase 2 trial on this, and it showed a pretty impressive clearance of liver fat that had been accumulated. Over 85% of patients achieved complete resolution of the fat that was in their liver. That's defined as having less than 5% liver fat at 48 weeks, which we think is due to the glucagon receptor agonism that this drug adds. As far as the toxicity and side effect profile, unfortunately, there does seem to be a higher side effect profile, particularly at max doses. There was an 18% dropout rate in this latest trial. And it does seem to increase resting heart rate by about 5 beats per minute, which does require some monitoring. So there's some concerns there, particularly at max doses. To me, Retatrutide represents a massive shift in how we approach fat loss. In the past, the only way we knew how to rev the engine was through stimulants like ephedra, which essentially dumped adrenaline to the system to force a higher heart rate and a higher metabolic rate to ultimately burn more calories. Now, Retatrutide achieves a similar metabolic increase, but it does so through hormonal signaling, specifically through the glucagon receptor rather than the catecholamine dump. It is a more sophisticated way to turn up the furnace. And that's what makes Retatrutide so different from the previous generations of anti-obesity medications like Ozempic or Zepbound. While older drugs mostly focused on slowing down the gut and telling the brain you're full, Retatrutide is actively increasing energy expenditure through thermogenesis. It's essentially turning up the heat in the fat cells and the liver. Now, Austin, when you see a drug that is revving the engine this hard to clear liver fat, what are your primary concerns regarding cardiovascular stress in this population, if any at all?
Yeah, I would say a few things. I share your, enthusiasm and for this medication. I think it is, if we're calling it a peptide as part of this podcast, it is likely to be super effective and super beneficial for the population once it finishes up its trials and very likely ends up getting approved. I do not claim to be, an expert on the mechanistic implications of glucagon receptor agonism outside of kind of the more general descriptions that we've laid out here. I am more reluctant to characterize it as in any way meaningfully similar to ephedra. I think that is probably would spook more people off because anytime in recent years with respect to GLP-1 conversations, these meds have come up. People say, "Oh, well, they remember what happened in the '90s, right?" And it's like, look, we're in a different time now. We're not seeing the same signals in the data for these medications, and so when it comes to accelerating this or cardiovascular stress, quote unquote, I have a few thoughts. You're right that a lot of these tend to raise resting heart rate by a little bit. They tend to actually lower, quote unquote, heart rate variability by a little bit of, again, unclear real consequences, but those are things that we've noted. Now, if somebody is going to experience harm from that cardiovascular implication, I would expect that the people who are at highest cardiovascular risk at baseline who are exposed to these medicines are going to be the first to show that sort of harm, right? And the worst would be situations where people, for example, have significant heart failure, especially heart failure with reduced ejection fraction, where their heart is not functioning well, not pumping well, they don't really tend to tolerate, cranking up their heart rate and various other sorts of things. And so, in those populations, if we start to see signals of, oh, this is like they're dying more or getting hospitalized more, things like that, okay, then that is a signal that is worth paying attention to. Now, it might lead to, for example, saying that these meds shouldn't be used in that population. And we can study it a bit more in people who don't have heart failure, or those who have heart failure but have preserved ejection fraction, or those who just have coronary disease, in whom many of these drugs have already been studied and they actually show benefit, right? And so I'm reluctant at this time, to summarize, to make any assumptions about cardiovascular implications outside of what the evidence shows us, because these are going to be studied on a very large scale in a lot of populations, many of whom either have diagnosed or underlying undiagnosed cardiovascular disease. And so it's going to be a situation where, well, we're just going to see what the outcomes are. It may end up being that the loss in body fat, improvement in insulin sensitivity, resolving diabetes, resolving fatty liver disease, maybe that outweighs any potential negative effects of a few beats per minute higher resting heart rate. I wouldn't be actually surprised at all if that ends up being the case. So it's a TBD in my mind. I don't have the same types of concerns, at the start here as I would have, about the drugs that were being used in the 90s, or like somebody saying, I'm going to use dinitrophenol to try to accelerate my metabolism. Like, that's a totally different category of like accelerant. So I'm reluctant to kind of describe this in that way, just to not muddy the waters about how these drugs really work and the potential implications, safety or efficacy wise.
How familiar are you with the fen-phen saga?
We've talked about it. We've talked about it before. That was actually identified relatively quickly at the time in terms of the negative side effects in valvular heart disease, pulmonary hypertension, things like that.
Yeah, it's kind of interesting because fen-phen itself, so phentermine and fenfluramine, these were both agents that were approved in isolation and then subsequently paired together kind of off label. So it was not like an FDA approved sort of thing, but effectively there was a single study that was published in the early 90s by an individual showing, oh, look, weight loss with this thing, right? And that was like early 90s, but it wasn't until later in 96 when a different patentable version of it called Redux got on the market. But there was like concerns about valvular heart disease, pulmonary hypertension, stuff like that were like raised prior to it being approved. But ultimately it got past approval. And then, as you mentioned, pretty shortly thereafter, they were like, no, this does cause problems. We need to pull it from the market. So, there was some regulatory issues there. But if you compare the amount of evidence that was available on fen-phen, the thing that wasn't really FDA approved, and then Redux, the thing that was FDA approved, if you compare the evidence we have on Ozempic, Wegovy, Zepbound, Mounjaro, and even now Retatrutide, to what we had evidence-wise on that, it's overwhelming.
Not even close. Yeah.
It's not even close. Yeah. So people are like, well, look at the cautionary tale about fen-phen. I'm like, yeah, the cautionary tale wasn't really good evidence on it, and people were using it anyway. Kind of like peptides.
Yep. And one of the nice things about these GLP-1 meds, including, Reta, that's, again, we're anticipating is coming out, is that there is a dose range, right? And people are different. And this has been my experience so far. I've worked with lots of people now on these medicines, and everybody responds kind of differently. And so to the extent that we're seeing maybe a little bit more side effects in some of the trials, that might mean that we adjust the, dose range to achieve the intended effects. Some people do just fine on much lower doses, and we don't tend to see those things. And some people need to max it out to get the effect that we're looking for. And that's the beauty of it. You can kind of sliding scale it based on what people need.
Yep. All right, moving on into the same category, these metabolic modulators. We're moving to a zombie drug, AOD 9604. AOD stands for anti-obesity drug. Austin, you ever heard of this thing?
I don't think so. No.
Okay, well, this was touted as the holy grail of fat loss about 30 years ago.
Why are we still talking about it?
Well, that's a great question. Yeah, if you look on Reddit, this is like a fat-burning blade of human growth hormone with none of the metabolic baggage like water retention, risk of diabetes, joint pain, etc. It's marketed as a fat melter that leaves the muscle untouched. And so this was developed in Australia in the late 90s as a obesity drug. And so the thought here is that this is a like segment or a fraction of human growth hormone. It binds to fat cells to stimulate the breakdown of fat. We call that lipolysis, while ignoring other receptors that cause unwanted growth or metabolic damage. As far as the literature on this, human data confirms this drug is a proven failure. In a large 24-week trial of over 500 subjects, this particular drug failed to show statistically significant weight loss over placebo. While safety is pretty good for it based on these human trials, it doesn't seem to work. And so safe and useless is a pretty poor value proposition.
I got a lot of things I can suggest to you that that have the same effect.
Yeah. And so I don't know why people are still using this or advocating for its use, particularly for weight loss, because there are so many better options that, again, safety profile is well characterized, monitoring profile well characterized, effects well characterized, and oh, by the way, it actually works. Whereas this particular drug, we know that it doesn't work.
Yeah, I'll do my favorite thing. I'll just put two graphs side by side, put the 24-week weight loss data of this, just blinded, anonymized, you don't know what the drug, what the intervention is, up against blinded, anonymized, you don't know what the drug is, 24-week weight loss data on tirzepatide. And you just get to pick which one you would rather take if your goal is weight loss. Would not be a contest.
Yeah, so unclear why this is still being sold or why people are still buying it. I think it's got to be, has to do something with like human growth hormone modulation. People are like, oh, human growth hormone, if I just need to affect that axis and I'm going to be great. I'm like,
if you're going to do that, like, again, we're very understanding of, people's intents and their goals and things like that here. And if we're going to take a very harm reduction type perspective, it's like, just go on tirzepatide and then just take testosterone. Like,
yeah. All right. We're moving on to MOTS-c. Have you ever heard of this?
I have actually seen this acronym, but not something that I've investigated myself.
Yeah, MOTS-c is billed as an exercise in a syringe. The claim is that it replicates the metabolic signals of a 5-mile run, forcing your body to burn fat, improve insulin sensitivity, and build endurance, even if you spend the day sitting on a couch. Now, the biohacking community is obsessed with this being an exercise mimetic. Austin, help people understand the difference between the body producing a signaling molecule naturally during a 5-mile run versus injecting a massive bolus of it into a otherwise sedentary body. Does the context of the signal matter?
Oh my gosh, my brain goes so many different places when I hear this question. We've talked a lot about the idea of it matters how you got there. When we talk about blood pressure, for example, it's like, oh, did your blood pressure go up because you have hypertension, or did it go up because you're actively exercising? The same with a lot of other things. When it comes to dietary fiber, did the fiber come in the form of an isolated fiber supplement, or did it come in the form of a persistent, chronic, high fiber, whole food dietary pattern? It does have fundamentally different effects. If the body produces a particular signal in response to exercise, especially with the demands of exercise, then if you take that same molecule and inject it in separately, does it deliver all the same benefits when it is given when there was no demand present in the first place? Kind of reminds me of when we talk about heart rate. Does getting your heart rate up from a panic attack give you the same cardiovascular aerobic adaptations as actually doing the thing that demanded the heart rate increase? All of these things, the context fundamentally differentiates the downstream health impacts that we can expect. That's not to say that there can be no plausible or potential benefit from an isolated, molecular signal like this. Again, I remain open to the possibility, pending human data showing it to me. But I will always have a baseline degree of kind of like my prior will be a low probability of at least the same benefits as you would expect from exercise, because again, the context, the demand, things like that are different. If there's a partial effect, maybe that partial effect is worthwhile if it can be shown, because there are some people who maybe are physically unable to meet current physical activity guidelines. And so if you can get them at least part of the way there, great, fantastic. It's a tool, right? We are not like moralizing around the use of these tools, just like with respect to GLP-1 receptor agonists when it comes to treating obesity. So show me, the effect, and then I will kind of put it in context and judge its potential uses.
Tell me what you think about this analogy. When we talk about like fiber intake, for example, or eating fruits and vegetables, we talk about this food matrix effect, in that it's not just the fiber that's delivered by the fruits or vegetable, but it also co-occurs with flavonoids, polyphenols, etc. There's more than just the fiber. The food is greater than the sum of its parts. What about an exercise matrix effect? So you're getting like one thing, one aspect of it, but you don't have the entire symphony that you experience from exercise. You're just getting one instrument, one molecule instead of the whole band. Is that kind of...
Exactly. That's it.
All right. So this was discovered in 2015, and at the time it was a breakthrough because it was encoded by the mitochondrial DNA, the powerhouse of the cell, rather than the cell's main nucleus. So what it does, or what it's supposed to do, is when your mitochondria are drained by stress or exercise, the MOTS-c tells the rest of the cell to turn on power save mode. In the body, this power save mode means activating AMP kinase, which forces the cell to stop building new stuff and start burning fat and sugar for fuel. Now, as far as the evidence, we don't have any on humans. We know that humans produce this naturally during a workout, but no study has ever shown that injecting it into a human improves fitness. The bottom line on MOTS-c is that while the rodent data on strength and endurance, it looks incredible, we simply don't know if that translates to a human being. We are seeing a 12-fold increase in natural MOTS-c during exercise, but injecting a synthetic version into an otherwise sedentary human is a completely different biological event. Until we see human trials, it's pretty much pure speculation.
Yep.
We don't know
Agree.
if it works.
Mhm.
I'm pretty skeptical on this right now. We need some human data, especially on like safety and side effect profile first, and then we need efficacy data. And then afterwards, if it passes all of that, then I suspect this would be a blockbuster, like if true.
Yeah, I think that's a helpful paradigm for people to think about when approaching the potential use of these things. First, does it appear to be safe? Second, does it appear to do the thing that it's being claimed to do? And then you get to weigh those things on the back end and decide if it's worthwhile for you in terms of cost and access and all sorts of other things. But we're like at the very early stages of that journey, it seems here, and I'm not sensing that there's like an overwhelming amount of active research happening that we're like expecting at any time soon.
That's what I'm saying. We would have heard about it.
Yeah, exactly.
We would
There's
hear
been a
about
lot of these kind of exercise mimetics that have been hyped over the years, and none of them have really panned
it.
out.
Full.
Yeah.
All right, moving on to 5-amino-1-MQ. Now, on social media and Reddit, this is being sold as a fix to a broken metabolism. The claim is that it prevents your metabolic rate from slowing down as you age by inhibiting an enzyme called NNMT. Now, mechanistically, by blocking that enzyme, 5-amino-1-MQ indirectly raises NAD+ levels, specifically within your fat cells. The theory is that this shifts the cell from a fat storing mode into a fat burning mode. And in mouse studies, the results were pretty impressive. There was a 30% reduction in body fat and even some increases in muscle strength. But when we look at how 5-amino-1-MQ actually works in these mouse models, it's not just about shrinking the number on the scale. In fact, it actually targets the fat cell size itself. Now, by inhibiting that NNMT enzyme, it prevents the hypertrophy or the overexpansion of individual fat cells. So again, in these studies, the mice saw a 30% reduction in total body fat. But here's the kicker. They did this while staying on a high-fat diet and without exercising. And I think this is why the biohacking community is so obsessed with this agent. They see it as a potential exercise in a pill. However, there's currently 0 published human clinical trial data for 5-amino-1-MQ. We don't know the safety profile, and we certainly don't know if those fat loss results translate to humans in the real world. I think, though, we have to be realistic. A mouse in a controlled lab environment is not a human living in the real world. This goes back to that NAD+ correlation we see with NMN and NR supplementation. Just because you can force a fat cell to behave differently in a rodent doesn't mean that you'll see a meaningful, safe change in human body composition without addressing major lifestyle change. Austin, this is exactly why the longevity space is so cluttered right now. We have these incredible mechanistic stories about NAD+ and fat cell metabolism, but the human data isn't just there yet.
Yeah, the NR, NMN supplementation space is a big one in like anti-aging circles and longevity circles and things like that. And my current understanding is that it has not been proven or shown effective enough at this point in order for me to actually spend the time to learn about it in great detail, right? If it does not seem to be that potent of an effect for good things that we're looking for in a safe way, then I'm at this point not going to bother. Too busy dealing with actual things that work. So that's my approach.
Yeah, there you go. All right, moving on to the lifestyle drugs. We have melanotan 2 and PT-141. Now, these are often called Barbie drugs because they affect tanning, appetite, and libido. Now, both molecules work on the melanocortin system in the brain, which acts like a master control panel for survival. They just have very different levels of precision. Melanotan 2 is a non-selective agonist. It hits the tanning receptors, the appetite suppression receptors, and the arousal receptors all at once. The problem is that it also carries a significant side effect profile, including intense nausea and documented case reports of rhabdomyolysis and kidney failure. By contrast, PT-141, which is also known as bremelanotide, it's a much more selective agonist. It's designed to target the receptors specifically associated with libido and sexual arousal while leaving the tanning and the stress signals alone. In fact, PT-141 is actually an FDA-approved medication for hypoactive sexual desire disorder in women, and it's often used off-label for men who don't respond well to traditional PDE5 inhibitors like Viagra Cialis, so it's a legitimate pharmaceutical with a much better characterized safety profile than the research chemicals people are buying online. As far as the toxicity side effect profile, main thing here is nausea with PT-141. It has a 40% rate of nausea. And because it acts on the brain, some men report spontaneous erections that occur without physical stimulation, which can last several hours, but are generally not classified as priapism, which don't Google how to treat priapism.
Spare yourself.
Spare yourself. As far as melanotan 2, this appears to have a more significant side effect profile. Case reports of muscle breakdown like rhabdomyolysis and kidney failure. So to summarize, I think melanotan 2 may be effective for tanning, but lacks safety data and has more red flags than DNP, that infamous, often fatal fat burner we did a mystery case on. PT-141 seems to be pretty proven for sexual health, but the nausea side effect is probably what's limited for being like a blockbuster Barbie drug or lifestyle drug. Austin, in clinical practice, when a drug has that high of a side effect burden, like with the nausea, for a quality of life issue like libido, how do you approach the informed consent conversation with the patient?
Yeah, tons of this involves a conversation with the person about what their goals are and how far they're willing to go to achieve those goals. And so if they are, at their wits' end and looking for something to help with this particular issue, then that may be a risk that they're willing to accept. I would say a couple things, though, even as part of that conversation, because it's difficult for me to imagine that, I'm taking a drug to really crank up my libido, and then if it's going to make me throw up, that's going to be the thing that, keeps me in the mood. And so that conversation would involve a couple things. One has to do with dosing, right? Because many medicines might have a high incidence of GI-related side effects. It could be a dose response type effect. It could be something that requires a little bit of adaptation to kind of get over that hump. That's actually something that we're seeing with, many patients who take GLP-1 receptor agonists. Nausea is the most common upfront side effect that they take, whether at the starter dose or with dose escalations. Sometimes that takes a little bit of time to get used to. Sometimes we use some anti-nausea medicines at the same time as the medicine or the dose escalation to try to mitigate that. And then in this context, where it's probably, I would imagine, something that has like a time component to it, you take it in a particular context, maybe trying it not when you're, getting ready, so that you don't learn for the first time whether you're in the 40% or not. So starting a low dose separately as a tester might be a way to go. But that would be how I would approach this in practice, is like, how far are you willing to go? What are you willing to risk? If you're willing to experience some nausea, and then testing it out at a low dose separately, and then you can kind of introduce it in the right context to see if it helps you.
Yeah, no, that's a good clinical pearl there. All right, so let's summarize this. It's like a little if-then sort of discussion. So with respect to peptides, if you want more muscle mass, more muscle hypertrophy, think that peptides right now are a bad trade. Have not seen an agent with good evidence for improving actual muscle tissue and subsequent performance like strength, power, etc. So I don't think that would be a good option to use to gain muscle mass. You mentioned it earlier. You're like, look, if you want to get some of these benefits, just take tirzepatide and testosterone. It's like, look, we have way more data on anabolic steroids as far as like not only on their efficacy, but also safety and monitoring. And
Yes.
so I think the thought is that, peptides are way safer, one, and then two, people can get them without having to go through as backdoor of channels. Like Vinny at the Gold's Gym
right. Yeah.
down the street doesn't have to like give you vials in like a dark corner or dark alley. So, but I'm not telling anybody to take anabolic steroids. I'm just saying that when I look at the sort of evidence on this, I'm like, well, I know those things work, and I know what to monitor, and I just more well characterized. I'm like, it seems like a better option, to be honest.
Yeah, I agree. That's it. I have the same take. I'm not going around recommending it, but if I have somebody in front of me who's like, look, I'm going to take something.
I'm going to take something.
What's it going to be?
Yeah.
Right? I'm going to take the thing we know more about and that I know how to monitor than the thing we don't.
Yeah. For injury, again, with respect to peptides, there seems to be some non-zero risk, whether it's high risk, moderate risk, low risk. We just don't know because the data is kind of absent. But the reward is even more unknown. So I don't think I can recommend using BPC-157 or TB500. I have concerns about their mechanisms and just, again, lack of human data for safety, efficacy, monitoring. Everything's anecdotal, right? That's a problem. And then without any real efficacy data, just seems like a bad trade-off. I would try to optimize load management instead. That seems like a much more successful and less risky proposition.
Yeah, to an extent. I mean, both of us have had our share of injuries participating in all sorts of different sports, and we've been fortunate to be able to rehab essentially all of them to this point. That is not to say that that is going to be the case for everyone in all circumstances of musculoskeletal injury, and so I totally understand where your mind can go when you're in the depth, especially of severe pain or persistent pain that is difficult to rehab. You're willing to try a whole lot of things. This would not be very high on my list of things to try, especially early on. Be way far down that list, and even then, I have my concerns about it at this point. I wish, somebody would. I just see so many people on these podcasts, people who claim that they run clinics, and they're seeing all these people that are having miraculous results, and it's like, would it be so difficult, so difficult to, even a small pilot, placebo controlled trial, like you would be the leader of the field automatically if you just ran one of these things, right? But instead, they're obviously quite lucrative practices that are doling this stuff out. Well, I would say this stuff, but whatever it is, because again, the purity aspect and things like that remains in question when it's being formulated in the way that it is. But, you would be immediately at the forefront of this field if you were able to just document these data, show these results, right? We see this in a lot of, again, I don't want to like lump these in with like all folks in the quack space, but even, during pandemic times, there was all sorts of claims about cures for infections. And now there's still people on the internet talking about the use of some of these drugs to cure cancer. And it's like, look, if you're curing all these cancers, if you're curing Parkinson's disease with febendazole and stuff like that I see on the internet, I'm like, just document it. You would, again, revolutionize all of medicine because of how common these conditions are. It would not be that difficult if the effects are as large as you say. You actually don't need a very large sample size. You don't even need a very long study duration. Like, it would be trivially easy to show with the sizes of effects that you're claiming.
Big if true.
Big if, very, very big if true. And so that's what we would, prefer to see, but we don't yet.
All right, so we talked about building muscle and strength. We talked about what happens if you're injured. And then now if you want fat loss and you're in the market for peptides, don't buy the zombie. Like AOD 9604 failed clinical trials. And so I think we would both agree, and we've talked about this so many times on the podcast, but if you're an individual who would benefit from one of these anti-obesity medications, whether it's semaglutide, tirzepatide, and potentially a retatrutide when it's approved, there are many avenues for you to obtain this in a way that is not only safe, you know what you're getting, somebody's monitoring you appropriately, but also these things actually work. So like, we would recommend that. Probably not a DIY situation, although this is an interesting question maybe. We know that fortunately the prices on these medications are coming down, right? And so while there's some controversy around compounding pharmacies who continue to make these, even though against the FDA's sort of ruling on this, what do you think about, there's like pharmaceutical grade versus compounding pharmacy versus research chemical? Do you think there's more risk than benefit for individuals using a research chemical like semaglutide compared to like getting the Ozempic or the Wegovy?
Yes, I think the spectrum follows exactly what you described. If I had my druthers, to use one of your sayings, that would be my order of preference if I had to choose. And it would, I see no scenario where I am personally willing to take any sort of research chemical. It's going to be pharmaceutical grade, and then in very rare situations, would I be pursuing compounding, and there'd have to be a good reason or justification for it. And there are very legitimate, valid reasons to use compounding pharmacies for all sorts of things, whether due to dose adjustments or due to, certain medicines, the way they're formulated might contain something that somebody is intolerant of or allergic to. There's all sorts of reasons to do that kind of thing. But research grade, yeah, I can't get behind that for Gen Pop.
Yeah. I think that just highlighted a very important takeaway here. We would both recommend pharmaceutical grade stuff. You know what you're getting. Look, the manufacturing standards are much higher. The amount of financial resources to make sure that you have, pure and materials to start with and end with, and testing along the way, all of that is like well established procedurally. You don't have that in research chemicals. And interestingly, I don't know if you pulled this study a while ago or if I did, but I remembered it and I instantly went to the right one. So there was some third-party testing done of research chemicals in the selective androgen receptor modulator space, so SARMs. And of the 44 tested products, no active compound was detected in 4 of the substances. Substances not listed on the label were contained in 11 of the compounds tested, and only 18 of the 44 products actually had what they said that was on the label in the thing.
That's kind of terrifying. I mean, to somebody who is not, in this space or thinking about these kind of things regularly, like I'm imagining, hey, I have a patient with, uncontrolled diabetes in front of me, or like they're in diabetic ketoacidosis, and I want to prescribe them some insulin to save their life, as I do very frequently. If less than half of the patients to whom I prescribed that actually ended up getting any degree of the actual drug in their prescription, that would be bad. That would be quite concerning. And so obviously we're not, in this context, dealing with such acute potential risks, like the person's likely to die on the matter of hours if they don't get the thing that I want them to get. But on a longer time span, you could end up with a similar type of thing, whether due to contamination, impurity, or if you think you're treating something that you're actually not treating. So it's kind of a scary stat to see the percentages of like, hey, almost 10% had none of the compound at all, and then a bunch, a quarter had a bunch of stuff that wasn't on the label. That's super concerning. And then only a tiny fraction had any degree of what it said it had. That's not acceptable, in my opinion, and not a risk I'd be willing to take personally.
Yeah, and that's just the like active compound.
Right.
Like we're not even like bring up heavy metal testing, for example, lead, arsenic, cadmium, mercury. Imagine the cost for like, high performance liquid chromatography to, make sure that it's not in there and to scrub the product of any residual agents, for a research chemical manufacturer.
Yeah.
Yeah, where's the FDA? We don't know. All right. So Austin, to bring this home, if you had to give a clinical pearl to the person who's currently staring at a vial of a research chemical they bought with Bitcoin, what is the one question they aren't asking themselves that they should be?
There are a lot of questions they should be asking, but I think if you had to ask one up front is like, what else could this thing be doing to me besides what I hope it is doing to me? And how many of those potential kind of what we'll call off-target effects am I willing to accept in this kind of really gray area of not even medicine, whatever this is?
Yeah, there are no biological free lunches. So that does wrap up our deep dive into the world of peptides. As we have discussed today, the gap between the marketing hype and the actual clinical evidence is currently a canyon. While the biochemistry of these molecules is fascinating, the reality is that the gray market carries significant risks, from impure manufacturing to unknown long-term effects on your endocrine and immune systems. And we're not trying to be anti-technology, but instead we want to be pro-evidence. And right now, the evidence suggests that most of these agents remain unproven for how they're being used. If you found this episode helpful, please leave us a 5-star review. It really helps drive traffic to our podcast so we can keep bringing you all the latest nuance in health and fitness. From everyone here at Barbell Medicine, I'm Dr. Jordan Feigenbaum. Special shout out to Dr. Austin Baraki for joining us. We'll catch you next week and every week right here on the Barbell Medicine Podcast.